Hello, welcome back to this another video. And in today's video, we are covering ARD section. Under ARD, we are doing the chapter called Agrometeorology. What I'm going to do is I'm going to revise this chapter of Agrometeorology, which I had read earlier. So, what is meteorology? Meteorology is the science of weather. It is essentially an interdisciplinary science because the atmosphere, land and ocean constitute an integrated system. Okay, then we have agricultural meteorology or agrometeorology is an interdisciplinary science concerned with discovering, defining and applying knowledge of the interactions between meteorological and hydrological factors and biological systems to practical use in agriculture. So use of meteorology for agricultural purposes is basically what we call as agricultural meteorology. Then we have meteorology versus agricultural meteorology, branch of atmospheric physics, branch of applied meteorology, or a branch of agriculture as it deals with agriculture. Then it is concerned with weather forecasting. It is concerned with improving quantity and quality of crop production through meteorological skills. The main aim here is to improve the crop yield and crop productivity for crop production. That is it. Then these are the institutions: IMD, Indian Meteorological Institution, World Meteorological Organization, ICAR, SAOs and IMD. Then we have importance of agrometeorology for crop production. The importance stays very simple. It is for optimum crop yield, for cost effective plowing, etc. So you can just read this in brief. Importance. Then we have that is difference between weather and climate. So this is something that we need to pay attention to while revising weather and climate. Weather is actually very short, and this is long term. So here you can see state of atmosphere at a specific time and place is called as weather, and long term agricultural weather patterns in this region, in any region, so is called as climate. So nature, it is short term and dynamic, and climate is always long term and relatively stable. Because we say that now the weather is windy, for example, we say today's weather is windy, then we say India has a subtropical climate. Otherwise we can say Africa is a tropical country, has tropical climate. So these are long term characteristics that generally do not change. Then we have weather is localized, climate is regional to global scale, describes current atmospheric conditions, forecasting, short-term forecasting using weather models, and then for climate we have long-term predictions using climate models and historical trends. Field of study, meteorology, and here it is climatology. To predictability, often uncertain in the short term, but climate is shows predictable long-term patterns. Factors affecting weather and climate. We will just have a brief, very brief overview of this. Then precipitation is a major constraint, or we can say a major factor affecting both weather and climate. Then we have ocean currents. Then we have atmospheric composition. Then we have soil types, prevailing winds, altitude, latitude, distance from the sea, and then relief and slope. Then we move on to the next topic, that is atmosphere. Okay. Atmosphere refers to the envelope of air surrounding the earth, composed of mixture of gases. However, 99% of the total mass of atmosphere combined with a height of 32. Okay, this is the composition of what we can say is composition of atmosphere. So let us start with composition of atmosphere. We have nitrogen, that is at 78.08%. Then we have oxygen at 20 point these many percentage, carbon dioxide, neon, helium, krypton, xenon and hydrogen. So these are the composition of atmosphere. Then we move on to the next, that is atmospheric constituents are of two types. There are permanent gases, then there are variable gases. Fixed remain in fixed proportion, and this vary in place and time. Then oxygen becomes negligible above 120 kilometers. We all know carbon dioxide and water vapor are mostly confined below 90 kilometers. Here we have ozone, acts as a protective filter, absorbs harmful ultraviolet radiations. Okay, water vapor present up to 4% of atmospheric volume. Okay, then dust particles mostly found in the lower stratosphere. Here we have structure of atmosphere. So for structure of atmosphere, just remember this mnemonic called trust me in the exam. From T we have troposphere, then from S we have stratosphere, then from M we have mesosphere, then from T we have thermosphere, and then from E we have exosphere. So tropo, strato, meso, thermo, exo. This becomes very easy for us to remember the exact layers of the atmosphere, and also help us in the examination as well. So this is the they have just given us the height, and what this does: exosphere, extremely low density, negligible temperature concept. Okay, then they have just gone into the details, like exact what happens in the mesosphere, thermosphere, ionosphere, exosphere. So as I had already studied this in the UPSC geography paper, so I'm just skipping it. And then we have climate. Climate depends on many factors, some of which are latitude, altitude, precipitation, topography, vegetation. And then latitude, according to latitude, whereby temperature and sunlight affects. So for tropical, equatorial region, what happens? Subtropical, temperate, polar. This is the table. Like for tropical, equatorial climate, the temperature is very high. Subtropical, high in summer, moderate in winter. This is for, you can see, India. Then for temperate we have both moderate type, and for polar we have extremely low temperatures. Then altitude, according to altitude the temperature changes. The average rate of decrease of temperature is about 6.5 degree per 1 kilometer. Then we have precipitation, rain, snow, sleet, hail, freezing rain, and they have just given us the terms related to precipitation. This is not required. Sleet, just have a brief overview of this. Sleet is what? Mixture of rain and snow. Thunderstorm is sudden electrical discharge. Dust storm is strong winds lifting dust, sand particles to great heights. Okay. Then we have topography. How topography is shaping our climate and weather. It creates a rain shadow effect. Rain shadow effect is, I think everybody knows what rain shadow effect is. Moist air rises along the windward side of the mountain. It cools, condenses, and produces produces heavy rainfall. The descending air on the leeward side becomes dry and warm. This results in the formation of rain shadow region. Then we have wind barrier effect. Mountain ranges block the movement of cold or dry winds. They help protect from extreme climatic conditions. Like Himalayas. Himalayas are one examples which protect us from very harsh windy winds coming from the northeastern sides. Then vegetation also affects climate. Then other factors as well. Then here we have the, I think one of the important thing is classification of climate. So these are the scholars that had classified climate classification. So this one of them is D. Condalone and another one is Köppen. I think we should just pay emphasis to what Köppen has given the classification, because when we study classical geography, what we do is we highly refer to Köppen's classification in most of the scenarios. Okay. Then we move on to the next. That is Carl Troll developed a classification specifically suited for agricultural purposes. Okay. So we will study Köppen's classification, Köppen's climatic classification in detail. Basis of his classification: mean temperature of the warmest and coldest months, precipitation of the wettest and driest months, seasonal distribution of rainfall. Then he has just given us the climate types from A. A means tropical climate, B means dry climate, C means temperate climate, D means cold climate, E means polar climate, H means highland climate. That is it. That was the Köppen's classification in very short terms. So what are the salient features? Based on temperature and precipitation thresholds, closely corresponds with natural vegetation zones. Then we have Thornweight climate classification. It is based on the concept of water balance, integration, precipitation, and potential evapotranspiration. So this is just the formula. One is equal to, okay. Then he has given us the climatic types: per humid, humid, moist subhumid, dry subhumid, semi-arid, and arid. Then we have Troll's classification. Then we have Troll's climate classification. In Troll's climate classification is based on the length of the humid period, which is crucial for crop growth. So it is concerned. It is very concerned with the humid period. It is the basis is number of humid months, and the climate types according to the humid months is arid, semi-arid, semi-arid dry, semi-arid wet. What are the salient features? Simple and crop oriented, usefulness for determining the length of growing season, and does not consider rainfall intensity. Okay. Now coming to this very important thing, that is ICAR climatic classification. The basis is moisture deficit index, MDI. MDI. So in this, MDI is equal to 100 into in bracket P minus PET upon PET. P meaning precipitation and PET means potential evapotranspiration. On this, they have given us three climatic types. First is subhumid, which is ranging from 0 to 0.0 to 33.33. Then we have semi-arid, and then we have arid. So this was just a formula that was given by ICAR climatic classification. And here they have given us the three main difference between the all climatic classification. So here we have to just lay emphasis on one thing, that is ICAR and Köppen. ICAR is based upon moisture deficit index, deficit oriented, PPET. Indian agriculture application suitability is region specific. Okay. Then we have, okay, so we move on to the next topic, that is scales of climate and their importance. Climate can be studied at different spatial and temporal scales depending on the extent of area and duration of atmospheric processes. These scales help in understanding weather patterns. Okay. So let us see what are these scales: horizontal scale, vertical scale, time scale. And based on this, we have microclimatic scale, planetary scale, synoptic scale, that is macroclimatic, mesoclimatic, regional, local, microclimatic, localized. Macroclimatic scale refers to large scale climatic and conditions extended over vast geographical area. It is further divided into planetary scale, covers global atmospheric circulation system, includes trade winds, westerlies, jet streams, Rossby waves. Synoptic scale covers large scale weather systems observed on weather maps, and it includes high and low pressure systems, air masses, fronts, cyclones. Then we move on to the next scale, that is mesoclimatic, also referred as local or regional scale climate. And it includes phenomena such as thunderstorms, tornadoes, and land or sea breezes. Then we have importance of climatic scales. Helps in weather forecasting, essential for agricultural planning, useful in disaster prediction, assists in urban planning and environmental management, aids in understanding local versus global climatic variations. Okay, then we move on to the next topic, that is crop weather advisory. Okay, crop weather advisory refers to the advanced prediction of weather conditions and the formulation of crop planning strategies based on these forecasts. It plays a crucial role in minimizing the adverse impacts of weather variability on agriculture. Okay, understood. Provides location specific advisory to farmers. Application: crop selection and sowing time, irrigation scheduling, fertilizer and pesticide application, and harvest planning. Then we have Indian Meteorological Department, IMD. Headquartered is in New Delhi. It is responsible for forecasting, naming, and issuing warnings. Mandate: real-time forecast based weather information to compile and provide meteorological statistics. Then in IMD we have Agricultural Meteorological Division. So in this, it is established at Pune, and objective is to minimizing the adverse impact of weather on climate, on agriculture. Then key services: preparation and dissemination of agricultural meteorological advisories, and these are the key services. Then another important thing that you have to notice, Agrometeorological Advisory Services, AAS in India, under Gramin Krishi Mausam Seva scheme to support farmers with weather-based crop management decisions. Features: medium range weather forecasts at district and block levels. Advisories are issued twice a week, that is Tuesday and Fridays. Then we have district agromet units, Krishi Vigyan Kendras. Okay. Dissemination of advisories. It is through SMS via Kisan portal, mobile applications Meghdoot and Kisan Suvidha. Then we have crop weather modeling. Refers to mathematical representation of crop growth and development, describing the interaction between crops and their above ground weather and below ground environments. Important variables. Okay. Then types of crop weather models, statistics. Okay, that is not needed. Model calibrating and validation. No, this is also not needed. Important crop weather models in India. This is something that I think we can have a look upon. This model, CERES, crop simulation model for rice, maize, sorghum, wheat. Yield application is yield simulation across regions. Then we have DSSAT, decision support system for crop modeling, and application is climate change impact assessment. Here we have another, that is high resolution climate projections. Another one is climate change studies in rice, productivity assessment under climate change. Okay. Then we have other crop models, and these are the basic crop models that we can have a overlook. And yeah, so the next topic is weather forecasting. Okay, so the next topic we have is weather forecasting. Weather forecasting is the advanced prediction of atmospheric conditions based on the analysis of present and past meteorological data. What is importance? Helps in agricultural planning, reduces risk from extreme weather events, supports disaster management, assists policy makers in long-term planning. Okay, then we have types of weather forecast. Nowcasting, that is 0 to 2 hours. Main users are general public disaster agencies. Prediction, immediate weather events such as thunderstorms or lightning. And then we have long range, that is beyond 10 days to seasonal. Monsoon forecast, seasonal deviations than normal. Okay, we have weather calendar. A weather calendar is a pictorial representation developed by IMD to provide farmers with integrated weather and crop informations. IMD classification access. Okay, standardized IMD terminology, and in this heat wave, temperature exceeding more than 4.5 degree above normal is termed as heat wave. Severe heat wave is temperature exceeding 47 degrees Celsius. Cold wave is significant fall in minimum temperature below normal, and severe cold wave is minimum temperature which is less than or equal to 2 degrees Celsius. Then we have clouds. I think everybody knows about clouds, so I won't go into the detail of the clouds because I have already revised it in my geography class of UPSC. Then surface heating, orographic uplift, frontal uplifting, convergence. I will just revise this, that is types of clouds, and which I feel is very important considering the rest of the things. High level clouds. Cirrus clouds are composed of ice crystals and they are very much high in the atmosphere. And cirrostratus are thin wheel like clouds. Cirrocumulus is small white patchy arranged in ripples. Just remember the names. This is high level, this is mid level, then this is low level. And I think in low level, just remember nimbostratus, stratus, and stratocumulus. Nimbostratus are thick dark clouds producing continuous rain or snow. That is it. For this, I don't think so you need to overemphasize upon the exact term. And the word of meaning alto is middle. Hence, it is given altostratus, altocumulus. Okay. Then clouds with vertical development, cumulus and cumulonimbus. Okay, and then we have significance of clouds, and yeah, then we have Cloud seeding. Cloud seeding is a weather modification technique developed to address water scarcity by enhancing precipitation. It involves artificial reduction. It involves artificial introduction of substances into clouds to stimulate the formation and growth of raindrops or ice crystals, thereby increasing rainfall or snowfall. And cold cloud seeding. Substances used are, just remember these names because in UPSC prelims also this question was asked. UPSC prelims 2025 if I'm correct. Silver iodide is used. Silver iodide or potassium iodide. Iodide compounds are used. Crystal grow fast, melt into raindrops as they pass through warmer layers. And another is warm cloud seeding, and in this they are using sodium chloride, calcium chloride, magnesium chloride. Okay, and everybody knows why this cloud seeding is done. It is basically for decreasing the temperature of a particular region or for stimulating the rain. Then we have monsoon. There are types of monsoon, that is southwest monsoon that we experience occur from June to September, contributes 80 to 95% of annual rainfall. And there is northeast monsoon which occurs from October to December, picks moisture from Bay of Bengal. It is like this, northeast. And then we have other monsoon periods, pre-monsoon, post-monsoons. Important terms related to monsoon, you can see it: anticyclone, storms, hurricane. Then there is types of phenomena, contour, lines joining equal elevation. So I think this must be a table, and it is a table. Okay, so I don't feel it to be that important because it is heavily terminology based and completely geography oriented instead of being closer to agriculture. So just revise some important and common topics, that is isobar, connecting lines, points of equal atmospheric pressure. Then isohaline is for salinity. Then isotope is for elements having equal number of neutrons. Then isophene is for lines connecting points of similar seasonal phenomenon. And then we have instruments and their use. So maximum thermometer records highest temperature during a period. Then we have dirograph. Dirograph is used for measuring continuous atmospheric pressure. Then we have heliograph. Heliograph is for duration of bright sunshine hours. Penetrometer for soil strength and compaction. And I guess that is it, because it is not feasible to revise all the terms here and to keep in mind. So just basic terms and basic concepts are enough for the revision of this topic, that is agrometeorology. You need to be very much precise in revising stuffs for such chapters, because the level of questions that are being asked in the previous year questions for both NABARD and RBI, considering this, I think it is sufficient what we have covered till now. So yeah, if you like the video, please stay tuned for more such topics. And there is also a separate playlist that I have made for both ESI, another course for ARD, another course for general PIB, and another course for general current affairs. So you can find this in the courses tab of the channel and you can watch those videos. So yeah, for the next video, please stay tuned and thank you so much.